Welcome to the deep dive. Today we're digging into a really fascinating idea, rain-powered solar panels. Basically turning wet weather into, well, energy. We've got a white paper here looking at whether this could actually work, specifically for a place like Chicago with its, very variable weather. Our mission today is to pull out the key takeaways on this tech.
Yeah, and what's really interesting here, I think, is how it tries to tackle solar power's biggest, well, headache,
Yeah.
intermittency.
Yeah.
Standard solar panels, they just don't do much when it's cloudy or raining. So this aims to generate some power even when the sun's hiding. We'll need to look at, how it works and if it's actually practical for a city famous for its unpredictable conditions.
Okay, before we get into the nitty-gritty of the new tech, maybe let's quickly paint a picture of Chicago's energy situation now. Historically, it's been big on coal and nuclear, right?
Yeah.
But there's a real push for renewables.
Oh, absolutely. Solar's grown quite a bit there. A lot of that is thanks to state programs like Illinois Shines. They offer these rebates, pretty significant ones, that can slash system costs, maybe up to 50%. Plus, you got the federal tax credit, another 30%.
Right. And we're seeing homeowners, especially out in the suburbs with larger systems, benefiting from net metering, too. Getting credits for pushing extra power back to the grid.
That's a key piece, yeah. But Illinois, while it's making progress, I think is ranked around 15th nationally in solar capacity. Over 2,000 megawatts installed. It still faces hurdles. There's some resistance from utilities towards all this decentralized solar.
Right. It's not just competition, is it? It's about managing the grid itself.
Exactly. Grid operators need predictable power. And integrating lots of intermittent sources, even these supplementary ones, well, it demands big upgrades, infrastructure, policy changes.
Yeah.
That's a real bottleneck. And then there's the obvious seasonal issue. I read about one Chicago homeowner, for instance, whose panels only covered maybe 18% of their needs in December.
Wow, only 18%.
Yeah, but then over 100% in the summer months. That perfectly highlights the intermittency problem this rain-powered tech hopes to chip away at.
Okay, so let's get into it. How exactly does this new tech plan to capture energy when it's raining, not shining?
Well, the idea is to integrate something called Triboelectric nanogenerators, TNGs for short, right onto the traditional solar PV cells.
TNG.
Yeah, think of them like super tiny static electricity generators. They basically convert the mechanical energy from raindrops hitting the surface, the friction, into a small electrical charge. A bit like rubbing a balloon on your jumper.
Huh. So friction from rain.
Precisely. Some designs are even using graphene layers, that super thin carbon sheet, to supposedly improve how electrons are transferred from the water droplets. There's work out of Soochow University, for example, where they developed this dual-layer tang that's transparent. It sits over the solar panel, lets it keep about maybe 6.5% photovoltaic efficiency, but also generates power from simulated rain.
That sounds pretty revolutionary. But like with any brand new tech, I imagine there are some big hurdles. What are the main challenges these lab prototypes face before, we could even think about using them widely?
Oh, definitely. That's the big question, isn't it? Well, the concept is clever. The actual energy you get from one raindrop hitting a tang is tiny, like incredibly small. We're talking picowatts, maybe 10 to the minus 12 watts.
Okay, that sounds minuscule.
It is. It really drives home that current tangs are nowhere near being a primary power source, not even close. Their value, at least right now, seems to be more about supplementing the PV panel when solar output drops, maybe powering tiny sensors or something. And then there's durability. These tang layers are incredibly thin. How do they hold up against hail, snow, freezing rain, big temperature swings, all things Chicago gets plenty of? So yeah, scaling up production and making them tough enough for the real world are major, major issues.
Okay, so let's connect that back to Chicago's climate. The city gets, around 154 rainy days a year, lots of overcast skies. That almost sounds perfect for a hybrid system on paper.
It does seem like a good fit, climate-wise.
So during those cloudy, rainy spells where the normal solar panel performance dips, the Tiang part could potentially kick in and offset some of that loss. Maybe even get some extra juice from melting snow in winter.
That's the potential, yes. Climate seems receptive. But let's keep it in perspective. Chicago still gets a decent amount of sun, somewhere between 1,600 and 2,400 hours a year, which is actually comparable to LA.
Really? Okay.
Yeah, so traditional PV solar will absolutely remain the main workhorse. These hybrid panels would be more like a resilience tool, a booster, not the primary engine. And economically, they're just not there yet, not commercially viable. A standard 25 kilowatt solar setup in Chicago costs maybe $3.50 per watt before incentives, pays back in 5-7 years. PNs? We don't have mass production, so the cost is unknown, though some researchers hope for commercialization in, say, 3 to 5 years.
Right. So, for this rain powered solar idea to actually become a real thing in Chicago, the white paper points to a few key needs. We need better material science, basically, more durable tang layers that actually generate more power and can survive Chicago weather.
Definitely. Material science breakthroughs are crucial, and better ways to integrate them with energy storage, like batteries. You need to smooth out that very intermittent tang output.
And maybe some pilot projects, testing them out on city buildings.
Exactly. Pilot programs would be essential to gather real-world data. And on the policy side, you'd probably need to see things like Illinois Shines potentially expanded to include TENS. Plus, getting utilities like ComEd on board to figure out fair compensation for any power these hybrid systems might produce.
Makes sense. Public awareness campaigns, too, maybe. Highlighting the potential benefits.
Yeah, framing it as both a climate solution and an energy independence tool.
Okay, so wrapping up our deep dive here, rain-powered solar panels. They seem like a promising technology, but definitely still in the early stages, especially for a city like Chicago. The focus right now should still be on installing standard solar PV systems, but Chicago's existing renewable energy framework, plus all this ongoing research, means it could be well-positioned to adopt these hybrid systems down the line.
I think that's right. And what's really potentially transformative, looking bigger picture, is this idea that innovation, investment in R&D, and smart policy could actually turn what we see as environmental challenges like loss of rain into assets,
Yeah.
into renewable energy sources. That could genuinely help Chicago move towards its goal of 100% clean electricity, whether that target is 2025 or 2035.
So here's a final thought for you to mull over. Could we reach a point where cities are judged not just by how sunny they are, but by how cleverly they harness all their weather, sun, rain, maybe even wind on a micro level to get to that 100% clean electricity goal? Something to think about next time you're watching the rain come down.